Okay, the next thing we're going to look at is gravity, or gravitation. It is probably the most important force when it comes to space, because it's it that governs how everything moves and evolves over time in the universe. So there was a story that Isaac Newton came up with this whenever he was sitting under a tree and an apple fell on his head. Probably not true. It's more likely that for a long time he observed things falling, and it may have been an apple falling from a tree that got him thinking. Doesn't tend to work, but if you get hit in the head, you all of a sudden come up with these great ideas. Otherwise, we'd all be doing it all the time. But what he said was, okay, that apple fell, and he asked why. And what he knew from his own laws was there must be a force acting on it. There must be a force pulling it downwards, and that accelerates downwards. And he then thought, okay, what if you had a really big tree? So we have a bigger tree. Would that apple also fall? And he thought it was reasonable enough to assume, yeah. And what if you just continue that idea and continue that idea with bigger and bigger and bigger trees until you have a tree that kind of reaches out into space? Would an apple that fell from it fall as well? And he then thought, okay, well, the thing that makes apples fall to the ground on Earth, if that force extends all the way out into space, it could be that same force that causes the moon to orbit around Earth. We'll talk more about that later. And also the same forces can cause the Earth to move around the sun. And that was his big idea. Now you can read through this little bit. But his theory basically said that gravitation is universal. So its effects are not only seen on Earth, but throughout our entire solar system and our entire universe. He then devised some equations that you don't look at until A level, that we could use those equations to predict, okay, well, if Earth is this far away from the sun, how long should it take it to go around it? And his equations matched with the measurements. So his theory became accepted across the world. And the key thing with his theory are these bits here. So gravity acts between objects which have mass. So certain forces, such as we have electrostatic repulsion and attraction, act between things that have charge. Two electrons will repel each other. We have magnets, so a north and a south will attract each other. But the thing that governs gravitation is the amount of mass that something has. So the more mass an object has, the greater the object's gravitational force that it will exert. But the bigger the distance from the objects, the size of its force decreases. Now, one of the interesting things about gravity is it's always attractive. So if I have two planets, they will be attracted towards each other. Gravity, in fact, is very, very weak, and you can see that because let's say you have a paperclip sitting on your table. All of Earth is pulling that gravity towards it, or is pulling that paperclip towards it. But a tiny little magnet can counteract that and lift it off the table. Gravity is very weak, but unlike most of the other forces, we don't get repulsion. So magnets will attract and repel. Charged particles will attract and repel, and it means that on the most part, those forces cancel out. Gravity is always attractive, therefore it tends to build up with large objects in the way that magnetism and electrostatics don't. So it's always attractive. If an object is bigger, more massive, then those forces get bigger. Okay. However, if the object moves further away, then the forces get less. And that's the key thing that you need to take away from this. Okay, try the questions below. So pause the video, try the questions, and then I'll post, well, I'll continue it on here, but pause it now, try the questions yourself, and then you can mark through them. So the first question says, the moon is smaller than the Earth, its mass is only about 1/6 of the Earth's mass. When an astronaut on the moon dropped an object and fell more slowly, explain why this is, and it is just that gravity is less. You should remember gravity on Earth is about 10 meters per second squared. I think on the moon it's about 1.6. And yes, that governs the force, but it's an acceleration. So things will fall more slowly on the moon than they will Earth. You stand on some bathroom scales and notice your weight is 720. You take a rocket to the moon and stand on the same scales on the moon's surface. What will be your weight on the surface of the moon? Now, because the moon's mass is a sixth of Earth's, gravity will be a sixth. Therefore, what we can do is we can just divide that by 6, and it gives us that it will be 120 newtons. Notice your mass won't change from place to place. Your mass in kilograms is just a measure of how much stuff makes you up. But the amount of gravity that gravity pulls in that will change, so your weight will change. Remember, weight is equal to mass times gravity. So this doesn't change, but this will change from place to place in the universe. On which planet in the solar system would you weigh the most? It is Jupiter, because it's the most massive planet. Now, in fact, Jupiter's also very big, so you're quite far away if you run it. Well, not that it has a surface, but the edge of it. You're quite far away from its center of mass, therefore it's not maybe as big as we think, but gravity on Jupiter is about 25 meters per second squared, which means if you landed, if you were able to, on a spacecraft, jumped out, you would fall so fast. You know, you could break your legs jumping off a chair on Jupiter. Also, it's so large that your body would find it hard to deal with it. It'd be like walking around with giving yourself a piggyback and someone who's half your weight a piggyback all the time. Mercury and Mars are too small to have an atmosphere. Explain this. It is just that gravity on those planets is so small it cannot keep hold or really attract gas particles enough. Now, it's a slight problem on Earth because things like helium and hydrogen will float off into space because our gravity is not strong enough to hold on to them. But it means even if we thought, okay, we could go to Mars, we could just release a whole load of gas there and then it would have an atmosphere that we could breathe. Over time, it would just float off into space because gravity isn't strong enough.